Okay, we'll start talking about the quadratic equations by dealing with square roots here in 9.2. So our goal here is to solve a quadratic equation by finding its square roots. And here we go. Let's define a quadratic equation. So it looks a little bit like this. It can be, let's say that it's a quadratic equation is an equation that can be written in the standard form. How about form? Ax squared plus bx plus c equals 0. The a is going to be a number, the b is going to be a number, and the c is going to be a number. Sometimes you'll see these where maybe there's no x there or something like that, or maybe there's no c, but usually going to have this x squared here. So one other thing we should probably write here is that, let's say that a, we'll just write this kind of quickly, a cannot equal 0. So we'll write it like this, a cannot equal 0. Now at the bottom of the page, oops, let's move that back up there. At the bottom of the page, here we have solving x squared equals d by finding square roots. Okay, so this alludes a little bit back to what we were talking about in the previous section 9.1. If d is ever bigger than 0, so if x squared equals d, think about 4 squared equals 16, something like that. But if d is greater than 0, here's what we know, that this answer has two solutions. And we kind of write them like this. We talked a little bit about this in our notes in the last chapter, but we write it like this: plus or minus square root of d. Okay? Now, if d equals 0, think about how many solutions it might have. It's not going to have two, because you can't have minus 0 or negative 0. So it's going to have one solution, and that solution, when d equals 0, we're looking for a number that, when you square it, it equals 0. That is 0. And then if d is ever less than 0, something like, let's say this is a negative 9 right there. There's really nothing that works, because a negative times a negative is a positive. Really, it comes out to a positive number. So here's how we write this one. We say that it has no real solution. There really is a solution, but for our purposes right now, there's no real solution. Now down to example 1, I'll move that back up there so you can see that again. No real solution when d is less than 0. Really what this is saying, by the way, is we're never going to be doing this. I'm going to draw this here and then I'll erase it. We're not going to be doing square root of negative 16, because nothing's going to work there that we know of right now. Okay, so example 1. So we're going to solve this equation. This one's not going to come out perfectly, but usually here's our idea. In general, we're going to try to write the solutions as integers, 3, 6, 11, something like that. We want it to come out nicely if we can, but otherwise we're going to write them as what are called radical expressions. Okay, so let's start right here. K squared equals 17. So we're looking for a number that times itself equals 17. Well, we know that 4 times 4 is 16, 5 times 5 is 25, so it's a little bit greater than 4, whatever this is, but we can't really come up with anything perfectly. So here's how we write this. We write it as, seems pretty easy, the square root of 17, and that's as good as you can get. Now, the thing we should probably write here is that this is going to be a plus minus, because the two solutions, if you take the square root of 17 times itself, it's going to come to 17. So we have one solution that's square root of 17, and then we also have the negative, or the opposite of the square root of 17, because this times itself is going to be a positive number. It's going to be 17. Now going back over here to letter B, p squared equals negative 4. Well, unfortunately, this one has no real solution, because nothing times itself is going to give us a negative number. So this is no real solution, because the square root of a real number is never negative. So there is no real solution.